Okay. So before we start doing these log properties, I just want to remind you of one very important concept. When we first learned logs, there were two things I wanted you to remember about them, right? Do you guys remember what those were? That's not one of them. They're exponents. Very good. What's the other one?
The log is greater than 0.
That's very important. Yes. Not one of the things I was looking for, but that'll help you find the domain, right? They're exponents, and they are the inverse of exponential functions. Very good. Okay, so if you guys can just remember those two things going forward, that logs are really exponents, and that logs are inverses or opposites of exponential functions, this will be easy. Okay? Before we even do these or talk about these, let me just ask you, what do you do with exponents when you're multiplying? You add them. What do you do with exponents when you're dividing by them? Subtract. What if you have an exponent with an exponent on the outside like this? You multiply. Makes sense, right? Oh, it doesn't? Do we need to shoot your... Okay. Well, I wouldn't say that, but I'll ignore her. That's fine. Okay. So, let's start with property number 1, okay? We'll just talk through these, and then we'll start using them, okay? What base is this log here? B. What's the base of the exponential function here? So what's going to happen? They cancel out, and you get x. Log base b and b to a power are opposites, just like multiplying is the opposite of division, right? So you're going to be left with just whatever is left, which is x in the exponent, okay? Does that make sense, that first one? Okay. This can be easily explained using either property, but what's the exponent of this b here? 1. So do you guys see why that's 1?
Yes.
Okay. So basically, log in any base with just that base always equal to 1. Okay. Here, log of any base, log base b, of 1 equals 0. How can we explain that? What's the exponential version of this? Yes, anything to the 0 is 1. Does that make sense? Okay, so that's property 1. Okay, here we have a product inside the log. What do we do when we multiply with exponents? You add them. So what are we going to do with logs? Same thing. We're going to add the two logs separately. Okay, you guys see how that works? So when you see multiplication, you're going to split it up and add, just like you do with exponents. You would add them. You're going to do the same with logs. When you're dividing, you subtract. Okay? Here we have log base b of some number to some power. What do you do with the power and the exponent? You multiply. So this exponent multiplies the log, which is an exponent. Okay? That's like this property up here. This m is an exponent, just like this little n is an exponent, and that multiplies the log, because that's the other exponent of the function. Okay? This one here, so using that property right above it, we can go the other way too. Anytime you have a number in front of a log, that can be written as the exponent of what's on the inside. So over here, you see this x right here? This x can be written as the exponent of p. I know it's kind of hard to see, but you got it in front of you. Okay? And this is like property 1, but backwards. Here we have log base b of b to a power, right? Here we have b to a power, but in the power we have log base b. Those are opposites. So all we're going to be left with is whatever's inside the log, which in this case is p to the x. Okay? And this last one is called the change of base formula. We will use it, but not as much as we probably used to, because your calculators will do logs in any base now, right? We don't have to like change them to base 10 or base E anymore. You can just do the alpha y equals and change it to whatever you need it to be. But you still need to know this property. You can change any base to a new base. That's what this is. This A, we're changing it to a new base B, as long as you divide x and A. X goes in the numerator, A goes to the denominator. Okay. Those are all the properties. I know that's a lot, especially if you've never seen logs before. We're going to go through some of these examples, and we'll do as many as we need. Okay. But I don't want to do necessarily all, I don't know how many we got here. 40 of them, maybe more than that, if you guys are starting to get the hang of it. Okay? So you guys got to be honest with me. Say, yeah, this makes sense, or let's do more, because I'm still not getting it. Yes? These are the rules, exactly. Just like exponents have their rules, so do logs. Okay? All right. So let's look at example A. And how nice, they told you which property to use in case you forget. Okay? Log base 4 of 4 to the, what exponent is here? What's the answer? Here? Maybe we will do all these. These are pretty quick problems. Okay? Do you guys see how we're getting 1 here? David? Yes, but we're doing this without. And even if you do have the calculator part, like if you have a calculator available, you still have to know these properties, because once we start having variables, like over here, can't type that in the calculator. But it still works the same. That's the whole point. Okay? All right, what are all these going to be here? Yeah, the log in any base of 1 is all 0. Okay? Log base 2 of 2 to something. It's just 5, because they're opposites. What base is this log? E. So what do we get? 2. What base is this log? And inside we got 10 to the third. So the answer is 3. Making sense? Okay. Let's go to example 2. Okay. Here what we're doing, and you'll see me hear this or say this quite a bit, we are condensing. Condensing means we're making it into just one single log. So we're taking a whole bunch of stuff and just putting it into one. We're shrinking the expression down, basically. Okay? So here, if we're adding, we multiply what? 9 and x. So this is log base 6 of 9x. Does that make sense? Okay, over here, this would be log base 7. All of these are being added again. So 2 times 5 times y. What is that? 10y. Okay. Here we get log base b of, if we multiply these, you get x plus x squared. Now I'll write that down here in case you forget how we got that, right? Oops. I know, but usually we go in order of what we're distributing. Does that make sense? Okay. Over here, why don't you guys do B and C on your own? Let's see what we can do with that. Yeah. Yeah. Okay, I'll give you a hint. Oh, you know what? I have a feeling that that's not, yeah, I think they meant 2 here. Make that a base 2, okay? You wouldn't actually be able to use those properties. You'd have to do something else to
So we're
to
not
switch.
gonna-
No, we're not going to see that.
So long space two parentheses. Two parentheses. Two parentheses.
1.
24 days. Right. A long space.
What's that? Yeah, if you can, like the numbers, you can actually multiply them. 7.
If you're adding, you multiply. If you're subtracting, you divide.
That is correct. Yeah, just try it. That one's going to be a little tricky, but I think once you see how it works, it'll be easy to remember.
24 over Z. X over
Yeah, sure. It should simplify just the one log, right?
Mm-hmm.
So wouldn't you just take, like, for the first one, you would do individually divide the first one and divide the second portion?
Which one are you looking at?
C, first one. I did log base 4, 5 over 2 times log base 4, A over B.
And then you can combine
And
that.
you can multiply
Yeah,
them.
yeah.
Make sure I wasn't making things up.
Or no, you take it out.
You forget something?
Don't forget it, remember it. I'm playing. Bye, Raul.
Okay, let's go through these.
Dude, I'm trying.
so confusing.
Log base 2 of 24 over Z. Here we're going to do the same thing. 14 divided by 2, though, 7. We're going to simplify it because we know what that is. Here we got variables, so we're not going to do much except x over x minus 2. You guys good with that one? Okay. Now this one, we got a whole bunch of stuff going on here. Here's the easiest way to do it, okay? When you guys think of negative exponents, where do those usually end up?
On the right.
The bottom, the denominator of the fraction, right? Does that make sense? You see this negative right here? And this negative right there? That means the 2 and the b are going to be what we're dividing by in the log. Okay? And then the ones that are positive, we just put those in the numerator and multiply those like normal. So we got 5, what else? An a. So this would be your answer. Yeah, and once you see that, you know, because a lot of times what people do, and I don't write this down, but I'll see students do this. Log base 4. And then they see, okay, so it's 5 divided by 2. And then they go times a. And then they go divided by b. And even though this isn't incorrect, this is a lot more complicated looking than this, right? Right. But yeah, if you just remember, anything with a minus in front of it goes to the denominator, it'll be easy. Okay? So what's this one going to be? What's the numerator? 6 and 2, we know is 12 when you multiply, right? And what goes to the denominator? 3 and d. Make sense?
Wait, why?
There'd be 3 over D because it's subtracting, right?
Oh, see, this is what I'm saying. So this negative and this negative mean both 3 and D go down here. You could also do this. Factor out the negative. So if you take the negative out, what do we do with 3 and D? We multiply them, right? So that means 3 and D are being multiplied, but there's a negative in front of both of those, so those both get divided. Okay? But if you just remember, the negative ones go to the denominator, positive ones go to the numerator. Yes?
Yeah, with the log 5, 6 plus log 5, bottom. I think you add them together to 6 and 2.
We multiply.
I thought only you multiply when there's like a parentheses.
We're currently adding, right? We're going the other way from addition to multiplication. Does that make sense? The adding will come in when we go the other way. Okay? Any questions on this page? Okay. So now we're going the reverse order. Okay? Here we're using the same properties, but we're doing what we call expanding, which means we're taking one log and we're blowing it up into as many logs as we can. Okay? If we see multiplication, what can we do? If we see multiplication, we're going to add, right? So this is log base 6 of 3 plus, there you go.
Oh, okay.
Makes sense?
Yeah.
What's this next one going to be then?
Subtract.
So it's log, we don't have to write base 10, but you should remember that this is base 10, right? Of 7 minus, yeah.
Can we write it if you want to?
If it helps you, yeah, absolutely. You guys okay skipping these?
Yes, yes, sir.
You guys should know the answers. If you want, write them in. Okay? Let's do C. Here we have multiple things in the numerator and the denominator. So this is going to look like these, where we have many logs with some minuses, some pluses, right? The 2 and the x are positive, so we do log base 5 of 2 plus log base 5 of x. Does that first part make sense?
Yeah.
But now we're dividing by 3 and also by y. So that means we're going to subtract, very good, log base 5 of 3, and I'm running out of space, I'll just go underneath, also minus log base 5 of y. Does that make sense? Okay. Let's do this one with variables. Log base 7 of x. We're multiplying, so now we're going to add log base 7 of whatever that is, 3 minus x. And now we're dividing by both 5 and y. So what's the rest of it? Uh-huh. Good. Is that making sense to you guys? Okay. I know this is kind of a lot, but I think the more we practice it, the easier it gets, because eventually we're going to start solving equations, and this will be part of it, where you just have to like manipulate the expression and make it easier. Okay. Example 4, we're using this property. Whenever you have an exponent inside of a log, that can be written as a coefficient. That's the multiplication property. And vice versa. If you have a number in front of a log, you can put it in here and make it an exponent. Okay? So how could I write this? 5 times log base 4 of x. What about this one? What's the base?
10.
Okay, so either write it if it helps you or leave it, but make sure you know that that's base 10. What about this one? And do me a favor, always, especially if there's like an expression where you're adding or subtracting, if we're bringing that out as a coefficient, put it in parentheses. And then it's log base 8 of 3. Okay? Here we're doing the reverse. So it's log base 2 of what? A to the 5th. Next one is 9 to the 5b. And here it's natural log of 3 to the x minus 5. All right so far? Okay. Other property. All you need to remember for this one is that log base b and b to a power are opposites, right? So if we have 3 to the log base 3, you're going to get 7. What about here? X. What about here? A to the 3. Whatever's on the inside. Whatever's on the inside is what. Okay? Example 6 is kind of silly. I'm going to add more direction to that. Oh, I hope that didn't freeze. Okay. Let's do it in base 10 for A and base E for, oh, there's only one A. For the last, let's just call this B. Let's just call this C. B and C. Okay? So if we're using the change of base formula, we're in base 5, but we're going to change this to base 10. It would be log base 10, which again, you could either write the 10 or not, x divided by log A, or log base 10 of A. Okay? Yes.
So it will tell us what
It should. Yes. It can't just say use, because, I mean, the other way to do it then would be to just say, all right, if you didn't tell me a base, I'm going to pick whatever base I want. So then you could pick base 24 if you wanted to. These are all going to be the same. This? Yes. Oh, where was I looking? I'm looking up here. Thanks, Nicole. What should this be? 16 and 5. I was looking at the wrong thing. Sorry about that. Okay. For B and C, let's change these to base E. So what kind of logs are those? Natural log, and we'd have to do of 5 divided by natural log of 3. This formula is pretty easy to remember because if you're a visual person, you see how this 5 kind of sits above the 3? Well, that pretty much tells you where they go. Okay? This would be natural log of 3 divided by natural log of 7. Okay? You guys are doing phenomenal. All right. Well, the thing is, you guys, that I think now you know the properties. You're like, okay, we're done. But you know what? Now we're going to use them in context of actually just simplifying things. Okay, so let's look at A. See, now they don't tell us what properties to use. Okay. So you got to tell me, if I'm adding, what could I do? So this is log base 10 of what? 100. Okay. And so now you need to know, can we see? So there's a difference. When we had these expressions, right? We don't know what log base 10 of 16 is. We don't know what log base 10 of 5 is. Those are weird numbers, right? But you should know what log base 10 of 100 is. And if you don't know, that's okay. Figure it out. I'm asking you.
So,
Oh, we gotta plug it in.
No, without the calculator.
I have my phone out.
Remember those two things I told you at the beginning of class?
Yeah, inverse.
That logs are just exponents, right? If the base is 10, what exponent makes it 100?
Oh, two.
why not like
Okay. Why don't you guys try this one? Don't use the calculator. These are not meant to be done. No, I said do not use it. Yes.
how would you how would you rewrite that?
So to figure it out? Good question. You guys, if you did not look at this and go, oh, that's just 2, we can figure it out to remind ourselves, right? If we don't know what it is, we can call this x, right? And then change it to exponential. What would it be? 10 to the what equals 100? Okay, what's this one going to be?
3.
Because 3 to the third is 27.
How did you do
54 divided by 2 is 27. And then we know 3 cubed is 27. Okay? All right, let's see what's going on here. 5 is the base, and then in the exponent, we got this weird thing that we're subtracting. Well, what can I do when I subtract? So, but when I do that, I shrink it to 1 log, right? So it's log base 5 of what? 3 over 9. Let's reduce that. 1/3. Okay. Now, if you know what log base 5 of 1/3 is, that's phenomenal. I don't. You shouldn't. I'd be a little worried if you did. Okay? But what do you see here? A 5 to a log base 5. What happens? They cancel. That's right. So what's left? 1/3. Well, I knew the answer, but I didn't know this part. I don't know what that is. That's a crazy number. Try this one here on your own. What'd you guys get?
64. Yeah.
Alrighty. Okay, look. I know we're doing a lot of little problems here. Let me just keep encouraging you. We're going to keep going as much as we can. But right now, the goal is that after we finish tomorrow, I want to give you 2 days in a row of just practice together in class and getting help. But if we need to spend 2 days on this, we don't have that luxury. Okay, so if we can get through this page and this, you guys are going to be in great shape so that you guys can get a lot of help and practice and have 2 days in a row of questions and working together. Okay? All right, let's go here. Okay, so we're trying to simplify this. Okay? Well, that means there's got to be a way They will, but we got to change this 125 first. 125 is 5, isn't it?
Yes.
And then it's 5 to the third. Oh, I didn't even see this.
Yeah.
We know the cube root of 125. That's 5. So what's this going to be? Very good. Put the calculator away.
So, in the test, are we allowed to use a calculator?
You're on the test. You're probably going to have variables, so you won't be able to. So if you can do it with numbers, having variables in there, it's going to be the same. So, okay. All right. What about this one? The fifth root of 16 is not a nice number. This is what I was thinking of before. But 16, can we rewrite that in a different base? 2 to the what? To the fourth. That's correct. And now a fifth root. Fifth root is really what exponent? Yeah, you're a step ahead of me. But yeah, it's to the 1/5, right? A fifth root is a 1/5 exponent. So now we really have log base 2 of 2 to the 4/5. So the answer is just 4/5. Right, because it's log base 2 of 2 to the 4/5. If this were 3, we wouldn't be able to do it, right? It's got to be the same base. Okay? Can you guys see what's going to happen here?
The ln and the e are gonna send.
So what's left? 7,
So
7 over 5. Because a fifth root, and I'll show you the work, it's ln e to the 7. A fifth root really is to the 1/5, so it's really natural log of e to the 7/5, and that's where we get the 7/5 from. But I think as you guys start seeing this, you'll just look at this and go, oh, that's just 7/5. Okay? All right, let's go to the next row. I don't see really anything we can do here, right? Except we can change these to change the base. You see how over here when we change the base, we changed it to a division problem? Let's see if we do that, if anything happens. Let's pick just regular logs, base 10. This is the same as log 7 divided by log 3 times log 9 divided by log 7. How does that help us? Yeah, so we actually can simplify it, and we're going to get log 9 over log 3.
why are you doing it?
Because that's what's left. This is on top, this is on the bottom, right? Yes. Again, you can use any base. If you wanted to use natural logs, it'd be the same answer, just natural log 9, natural log 3. Right? We're allowed to change it to whatever base we want to. Okay?
You can't simplify, right?
No, because this isn't like, if this were like this, log, but then base 3 of 9, then we can figure that out. But these are base 10, and we don't know what exponent makes a 10 of 9 and what exponent makes a 10 of 3. Does that make sense? Okay. This one, we can also do something similar, right? Log 13 over log 2 times log 32 over log 13. Log 13's cancel. So it's log 32 over log 2. Okay. All right, let's see what we can do here. This is the same as log of 5 divided by log 4 times log of 64 to the x over log 5. We can put it, yeah, we'll move it in the front. Yeah. So the log 5s cancel. This x can be rewritten as a coefficient, right? So this is the same as x log 64 over log 4.
Do we have to move it?
You know what? It depends what the directions say. Most of the times, my assumption is going to be yes, because they're not going to want any exponents in the log. So if you can get the exponents out of there, you're going to do that. Ooh, but wait a minute. I just saw something. As soon as I said we don't want exponents in the log, something just clicked. Can we change 64 to a different base? Even smaller. 4. So let's write it. X log, and then 64 is really 4 to what power? To the third. So there is a little hidden exponent in there. So what can we do with that one now? We can move that one to the front. So we get 3x log 4 over log 4. Oh, this is nice.
Oh my god, bro. No. What just happened?
Log 4's cancel. So your final answer is 3x. And you know what? I think that's actually going to happen with all these now that I'm looking at these. Isn't 9 the same as base 3?
Wrong pen.
We'll just keep going.
So it's 2.
Log of 3 squared over log 3. This 2 goes in front. So what's the final answer? 2. Can we do this one without doing all that mess? What's this one going to be? 2 to the what is this? 2 to the 5th. So the 5 goes in front, and it's just going to be 5 because log 2 over log 2 will cancel. Okay? All right. You know what? Let's just finish this page, and I think tomorrow we can probably just do this last one, and I'm thinking, yeah, 6 won't take us too long, I don't think. Oh, maybe it will. We'll see. Okay. All right, so now we're going to expanding again. Log base 5. And this is 25 plus log base 5 of x. You see what we're adding here? What base is 25? So that's really 5 squared, right? So this whole thing is going to become 2. However you want to think about it. If you change this to 5 squared, log base 5 of 5 to the something cancels and you get 2. You could also think 5 to what power is 25? 2, right? Let's go with this one. This is going to be the same as, what's the first step? Natural log of x minus 8 minus natural log of e to the 2x. And yes, you are correct. What happens with these here? They cancel, so it's just natural log of x minus 8 minus 2x. Okay. Here we're expanding. We got, do you guys see how many things we have in here? 1, 2, 3. So that means we're going to have a total of 3 logs. Does that make sense? Log of x. We're multiplying, so plus log of x plus 3. And then we're dividing, so what do we do next? Minus, can we do it in one step now? Where's this 8 going to go? In the front. So minus 8 log of x plus 5. Okay. Almost done, you guys. It's the exponent of the inside. So I'm just skipping that step. Instead of writing it to the 8th, I'm going to write it out in front.
She's talking about why is your x is
Oh, well, remember, actually David reminded us, not only are logs exponents and logs inverses of exponential functions, you told us that inside these always have to be greater than 0, right? So the reason they're saying x is greater than 0 is because if it's not, we have a negative and we can't do that. Does that make sense? Yeah, it has to be positive. Yeah, yeah. So it's assumed, yeah. All right. Let's see if we can now, this won't be quite as much writing. We're trying to go into one log, right? Let's see if we can do it in one step. Log base 3 of what? Where's this 6 going to go?
Use a 6.
Well, it's already on the outside. This goes as an exponent of u. Oh, that's what you meant. Okay. And then this 5 becomes the exponent of v, so what goes in here? U to the 6th. We're at O, and I totally read. I was writing it as a... Sorry. U to the 6th times v to the 5th. Addition means multiplication. Coefficients are really exponents. You'll be fine, David. Trust me. All right, let's do this one. Log base 7. This one is subtraction, so I am going to divide. On the bottom is x to the 11. And up here we have square root of x. Express powers as factors.
So half.
Is that what they mean? Let's see. What exponent is a square root? Half. And then you could now subtract exponents. 1/2 minus 11 is really 10.5. So you can write it like that. Okay? We'll pick up with this one tomorrow. Okay?
Oh,